Welcome back student, this is second lecture based on basic mathematics. In first lecture already we have covered the vectors, okay? Yes, and in this lecture we will be covering like differentiation, integrations, maxima, minima and trigonometric function, all these things we will be covering, okay? Yes, so the most important part of mathematics for us is what actually vectors, okay? And vector question has been asked like directly also, okay? Like a cross multiplication or dot multiplication and like orthogonal vectors, finding angle between vectors, these things they have asked directly in our exam also, okay? Yes, but very rarely, okay. So in this lecture we are learning about differentiation and integrations, very basic things, I think all of you already know, still let us do quick revision of them, okay. When we talk differentiation, what is the meaning of this, okay? Differentiation, okay. Differentiation means what? You have some object with you or anything, suppose you divide that into small parts, that's called what? Differentiation, okay. Big thing you making into what? Small part, that's called what? Differentiation. And small things when you make them together, that's called what? Your integration. Right now you are integrating, okay. Yeah, differentiating and integrating. So what happens here actually, what's mathematical meaning? Suppose like you say something average, there is the word average. Average means what? Like you say something change in y by change in what? X. That's called what? Your average, right? Yes. Okay. So this is called what? Average. Change in y by change in x is called what? Average, right? Now, suppose this average you talk for very small interval. Your del x is what? Very small. So you can put a limit like this one. Suppose you say that limit your del x or varies to almost equal to what? 0 or very small. Then this del y by del x you can also write as what? Dy by dx. Yes. What's the difference between this and this term? This tell you average, this tell you what the instant value, very small interval. This interval that you are talking here is what? Very small. So this is called what? Your instant value always, okay. That's called average value, you can say like this way, and this is called your instant value. For example, if I say like average velocity, I say to you, I say that what is average velocity of an object? How you will say? You will say like change in displacement ds by change in what? Time. That will be what? Your average velocity, okay. This is what? Your v average, correct. But I ask you what is instant velocity right now? I ask you what is instant velocity or instantaneous velocity? Then same thing you can also write like this way, ds by dt. Means this time interval will be very small, correct. So differentiation will talk about very small things, okay. Yes, okay. Three words we have here that you should understand. One word will come here is called what? Constant. One word will come is what? Variable. And one word will come is what? Function. These three words we will hear when we talk about differentiation. Constant means some value which is not changing with what? Time, or distance, anything which is what? Not changing just. So all the numbers like you 1 2 3, this pi and all these integers and these things are what? Constant things, right now. Yes, that doesn't change with time or distance, these things, okay, they are constant. So when you differentiate a constant, what answer comes? Always what? 0. So differentiate them, then constant answer becomes always what? 0. I gave in formula here, we will talk about this. Where is variable? Its value varies with what? Time, okay. Value varies. If you are doing with respect to time or with respect to distance, it does not matter what is the reference, but value will vary. Function tell you the relation that, look here, suppose I write that y is equal to what? F of x. Then y is a function of what? X, means y value depends directly on what? X, correct. These things will come. So now look here. There is nothing else there, we have just basic formulas only, this is all I have wrote, what that formula which we need, okay, for our physics, okay. So basic formula is what? If you want to differentiate any like x power n comes in front and x power what? N minus 1 comes here, right. This formula all you know, still I am writing, okay. If you differentiate something constant, then the answer directly becomes 0, correct na? Yes, constant differentiation becomes what? 0, okay. That's you know, and if you multiply two things, right, two variables are multiplied, u into v, you want to differentiate them, then you know this formula, you keep any one thing constant like u, then differentiate second thing, then you keep second thing constant and differentiate the first thing. This already came in our Newton's laws, I gave example, remember this formula came, what formula? Force is equal to what? first write like force is equal to what, dp by dt came, right? Then you said force is equal to d by dt of what, m into v. So m also can be variable and v also can be variable, right now. Then how we wrote this answer, remember we wrote like this one, first you keep m constant, then dv by dt, then you keep v constant, then dm by dt. This came on Newton's second law, right? So then we put condition here, remember that if velocity is constant or mass is constant, right, then we get again two formula, right? You say that your velocity is constant, velocity is not varying, then dv by dt terms becomes what, 0. That term becomes 0 means your answer becomes like v into what, dm by dt, right, if velocity constant. Or mass is constant, then dm by dt, this term becomes 0, so force becomes what, you know, ma, right? Yes, m into dv by dt, that comes, that's what, acceleration only, right? Yes. So that's the example of this type. Yes, this we have in our syllabus use. Okay. Yes. This division of two variables like u by v, I have not seen any chapter in physics. Still, I am writing this formula here. Not much useful for us, but this is useful. Okay. This we have in our syllabus like this example. Okay. So if you dividing two variable like u by v and you want to what, differentiate them, correct, then how you write the down variable, v into differentiation of first variable minus u into differentiation of what, down variable by v square. Okay, not much use in our physics, okay, for us NEET people. Okay, then logarithmic function, you have log of x, it becomes simply become 1 by x. Okay, exponential function e power x, the answer becomes same only, e power x only. With e power x, we have some number with this, like this example, e power a into x, a is some number or some constant, then how it becomes, like this time is same only, then a x differentiation becomes what, a. Okay, yes, this is called partial differentiation. Yes, sine becomes cos, cos become minus sine, tan becomes sec square. Okay, for us this much only we need. These are just, if you want to remember, it's okay. Cot become cosec square, minus cosec square, sec becomes sec and tan. Okay, cosec becomes what, cosec into what, cot. So these are not much important, these last three. For us these are only important. Also this we will not see much useful. These two only will come again and again for us. Okay, yes. Okay, this was about differentiation. Okay, differentiation means what, you taking average and average values there of anything, then you make this down value very very small. Then this become what, in what, like instant or what, your differential format. Okay, yes. So instant value itself called like differentiation simply. Okay, like instant velocity, so this is called differentiation of displacement with respect to time, that give what, instant velocity. Okay, means this thing is what, very very small, this always tends to what, 0. I wrote a little wrong here, this is what, x here actually, dx. Okay, yeah, x varies all close to what, tends to what, 0, very very small. Then this thing average we can write in terms of what, instant. Okay, yes. Okay, the opposite of this is what, your integration, right? Just opposite of differentiation is what, integration, right? Differentiation means making small parts of some big object, and here integration what, you small parts you combine and make a big part, that's called your integration, right? Okay, integrating. So a general formula, you know that integration symbol we write is what, this one, right? Yes, you put some variable here, whatever variable varies like x power n into what, dx. You integrate this, you get that x power n plus 1, this power is increased, and that total power you put what, down. In differentiation you put what, your power is what, reduced, right? Now integration, your power is what, increase of that variable, right? Suppose it what, x square, it becomes what, x cube. Okay, increase. Here its power is what, reduced. That's the main difference here. Okay, yeah. Now what happens, integration we have many type like definite, indefinite, we don't need to know all those things, just basic formula we need is what I wrote it here for us. Okay, yes. So main general formula, x power n into dx you already wrote. What happens when you integrate something now, always a constant comes here, always a constant, right? Every time I will write like constant, right? Yes, but when we talk a NEET exam, in physics this c will be always what, 0, maximum time actually it will be what, 0. Okay, so look here, if you want, like I compare both things, differentiation of constant becomes 0, but differentiation of constant is what, integration is what, not 0. Some constants give like 100 into dx, that become 100 into x, we are doing with respect to x. So whatever number here into what, x it come, plus some constants will come. Okay, u into v, not useful at all, they did not ask, like division and this multiplication of 2, integration is very difficult, they don't ask to us at all. Okay, still I wrote this formula here, you don't need to remember this. Okay, this time, and division itself I not wrote here, we don't need them 100%. Okay, for medical people. Okay, yes. like 1 by x into dx, that become what, log x, opposite of that. Okay, log x is what, 1 by x here, 1 by x into dx is what, log x. Okay, and this rule is same here also, what, your exponential function e power x, differentiation also become e power x, here also becomes same, only e power x into dx is what, e power x only. Okay, yes, this I not wrote here, we don't need that. Okay, sine is what, opposite, minus cos, you should give attention to minus and sine. Okay, like sine is what, positive cos x, and cos is what, minus sin x, here just opposite, sin x becomes what, your minus cos x, and cos x become what, sin x. Tan is what, okay, we don't need this also, because this also I not seen any chapter that we need integration of tan x for NEET. Okay, so still we need, then it's natural log of what, sec x plus constant. Okay, natural log of sec x, these also we don't need, so I not wrote those things here, this much only we need, this also we don't need. No need to remember this. If you have capacity to remember, just try to remember. We don't need this also. Okay. Yes, this much only we need for integration and what, differentiation, right? Okay, let's talk about trigonometry. Okay, some basics of this. So already know that we have a Pythagoras theorem which relate these three things. Yes, this angle theta, this is called what, perpendicular, this is called hypotenuse, and this side is called what, base. Okay. So first, what is angle here? Already we learned in our first chapter what definition of angle and how we measure it. So angle SI system, we measure what in radians, and we have learned what is the definition of radians. Radians simply like if you are moving in a circle like that way, you start from some point and you cover some distance like that way, that's angle, that's your arc length S, that's what radius R. Then theta is simply given by S by R, means arc length by radius, that's your angle, right? So in SI system the unit of angle is what, radian, but sometime we write degree also. So you should know some relation like time and degree also they can write, like you say 1 degree, we write this symbol is equal to what, 60 minute. Okay, we write like 60 days symbol, and also should know that 1 minute if I say, then it's also equal to what, your 60 second. So we write 60 double days like that way. Okay, with the relations you need to convert radian into degrees into radians. So it's very simple. Suppose you want to convert degree into radians, right now. So we know that how you will do, what you will do, simply just you multiply by pi by 180, that number you will multiply, you get answer what, in radians. Degrees you converting into radians, so what you do, write like this, multiply by what, pi by 180. Like 90 degree you want to write in radians, so you pi by 180 into 90 you put here, you get pi by 2 radian, right? Yes, or opposite you want to do, radians into degree you want to write, then what you do, simply you multiply by opposite of this. Okay, so you multiply by 180 by pi number, you will get your radians into what, degree, pi. Okay, pi means what, you know that 180, right? Suppose pi is equal to how many degrees you want, right? So 180 by pi into 180, that gives you simply what, pi answer, right now? Yes. So sorry, I said I think wrong, we converting what, radians into degrees. So radians you want to convert to degrees, so radians you multiply here, I say that pi radian is equal to how much degrees, so 180 by pi into pi, you get what, 180 degree. Okay, this you know already, actually simple thing. Okay, mainly what we need to do actually here is what, this trigonometry will be very useful. Okay, before that I tell you this relation between like hypotenuse, perpendicular and base. There is simple rule to write for this called what, Pandit Badri Prasad Hari Bol. Okay, look at this formula, Pandit Badri Prasad Hari Bol. You can remember by any some other tricks. So in this formula we know that when we talk like sine theta, alright. So we know that this by that is what, sine theta. If you cannot remember, then remember like this way. So P by H, the first thing, that's what your sine theta. Then cos theta is what your second thing, B by H, right? And your tan theta is this, P perpendicular base, and other theta which are opposite of them. So this value also can reverse. Opposite of sine is called what, cosec. So that will become H by P, right? Tan, cot is what, just opposite of this, B by what, P. Okay. Yes, so we know already these things. Okay. Okay. What mainly we need for our okay, from NEET point of view, actually when we learning the SHMs, waves and AC chapter and wave optics, we will see the equations of the waves there, like a particle oscillating equation of SHM. Then next chapter we will see the progressive wave, stationary wave, the equations we will see. There we have to convert them into what, sine format is given, we have to come to cosine format, cosine to sine, we have to calculate phase difference, means angle between two waves, where we need these rules actually all. So already you know actually, let me write here. Okay, first a simple thing is what, suppose this is some reference line always x, right? If you start measuring angle here and you going what in this direction, that's called what, your anti-clockwise, ACW, right? Then your angle is what, positive, correct? We call that angle as what, positive. This angle is what, positive theta. But if you go what in clockwise direction like this way, right? This is called clockwise, then your angle will be what, negative. So that horizontal line, positive x, that's what your reference line always. If you are moving upward, means anti-clockwise, your angle covered is called positive. If you move downward, angle we call what, negative, right? No, negative angle, right? Okay. So what I am saying, just already know that in which quadrant who is positive and who is negative, right? This is called your first quadrant, that's called second, that's called third. This all we have learned in junior classes. This angle 0 degree, here is no 90 degree, that's how much, 90 means 180, that's what your 2, how much, 70, that's also called what again, 360, one complete revolution. These four quadrants are there, and we know that in which quadrant who is positive. So so you have simple rule that also you can remember, like all silver, right, teacups, right, yes, all. So in first quadrant everybody is positive, all positive here, right, all positive, correct. And in this sine and opposite of that, that's what your cosec, they are what, only positive, right. Then next t, means tan and opposite tan, that's cot, they are only positive, right, yes. And this is what, cos and opposite of cos, which is called your sec, they are only positive, right. These rules already know. Why we need these rules now here? Because I told you in next chapters, SHMs, waves and alternating current and wave optics, we need to write the equations actually, equation of the wave, which always write in terms of sine and cosine. Like I say that SHM will like particle is what's the displacement particle, right, like a sine omega t, right, something plus what, some angle here, right, like this we will write always. So always we have to find phase difference, resultant amplitude, resultant intensity. So we need angle between these two waves. That will understand from this, like who is positive, who is negative, like here is given sine, minus sine, cosine, what is given. So need to see the angle between these two waves. So we will need all these that in those chapters, okay, right. So look here, these are simple where we have to convert this. I wrote all this, already you know all these things, still I am writing here, it's like sine pi plus theta, okay. Sine pi plus theta is what, minus sine theta, because sine is already 180 angle is there, right. Look here, already 180 angle is there, means pi, plus you add some more angle, means you will come in this quadrant. In this quadrant only tan and cot is what, positive. So this answer becomes what, negative, correct. But sine pi minus theta means you are already at this point, then subtract some angle, you come in this quadrant, right. 180 minus some angle, you come in this quadrant or that quadrant. In this both are what, so your sine is what, positive. So sine like 180 or pi, you say minus theta is what, become positive answer, right. Yes. So this all rules I wrote here, please check them with reference to this. If you remember this, that's simple already. Still I wrote all of them here. Okay, look here, suppose you check something else, you say like tan. You said that tan pi minus theta is coming minus sine theta. Why? Tan pi, you are already here, pi, correct. Then you subtract some angle. Subtract angle means you come in this quadrant, right. In this quadrant your only sine and cosec are what, positive. So tan will be negative answer. That's the road word here, right. Okay, let's check some here. So you say sine 90 minus theta is cos theta. You are at 90 here. Then subtract some angle. You coming in this region. That region is what, everything is positive. So this answer comes what, positive only, right. Yes. Okay, suppose this answer is coming negative. Look here, cos 90 plus theta, cos 90 plus theta. So look here, you are already at 90 here, plus you add some angle, correct na? You add some angle, you coming this region. So here become what, sine, correct na? Correct only, 90 plus theta minus sine theta. And so all these things just you can relate with this table. That's simple, I don't need to explain much. Okay, the angle values already you know. General angle we need is what, 0, 30, 45, 60 and 90 only. Other angles you can write from here itself, just opposite of them. So all these values already know, and how to calculate from that formula you know, okay. So sine 0 means 0, 30 is sine value is what, increasing with angle. Sine value is what, increasing like that way, but you see cosine value is what, increasing like that way, okay. Yeah, sine theta and theta are what, proportional. Theta increasing, sine theta will also increase, right. yes, but cos theta and theta are what? Inversely proportional, okay, yes, okay. Then what will happen? I wrote all these values already, you know these things, but sometime in our NEET exam they have asked these angles only so far, okay, they did not ask. Still for reference, these two other angles are which are also very popular, what? 53 degree and 37, okay, they are opposite to each other actually, and they are very popular. So those values also I wrote here, like sin 53 is what? 4 by 5, cos 53 is what? 3 by 5, then 10 you can divide them if you want. Sin 37 is just 3 by 5, they are just opposite if you see carefully, okay, yes. Okay, so these also they did not ask so far in our exam. Once they have asked some in our optics, but they gave value. They said like some angle was coming 53 degrees, so they said take sin 53 as 4 by 5. They said so. Generally they gives with question, but still you can remember them. Okay. So this much only you have. Just we have to write the use of this. I will tell you SHM and wave chapter only. Okay. I don't want to confuse here. Just right now remember or understand from this rule simply. Either you remember all these things or you remember understand this thing. Okay. That's more easier to understand here. Okay. Yes. Okay. These are the few additional formulas about trigonometries which we will need on in our physics. Look here. Sin A plus B, sin A cos B plus cos A sin B, sin A minus B is cos A plus B. This you just have to remember only. Okay. This formula already have seen in our which chapter? Friction, right? Turning around a circular rod, you need two things. Either you need friction or you need what? You say what? Angle of banking. So when you wrote this topic, when both we need, both are there, like angle of friction is there and banking also there. Friction and banking both are there, then you use this formula in that last step if you remember, right? Okay. This formula will be useful. Sin 2 sin A cos is very important in our projectile motion. Okay. When we write height and range, we will use this formula actually. Okay. And this formula will come in our optics. This formula and this formula will be used in optics. Means they comes in different chapters. Just you have to remember right now them. So use I will tell you with every chapter when the questions comes out to you. Okay. Yes. Okay, please so note down this formulas also. Okay, next point we are talking is about what? Maxima, and minima. Okay. Actually, use of this you already have learned in what? Your work energy power. Hope you remember the topic where we learn like equilibrium conditions, right? Na? In work energy power chapter I am talking, and it's about potential energy, right? So a system is an equilibrium with potential energy is what? Minimum, right? Na? Or maximum. So for that, if you have learned three type of equilibrium, if you remember that equilibrium can be stable, unstable or neutral equilibrium, right? So I wrote few conditions there, hope you remember them. That net for equilibrium, the net force should be equal to what? 0, right? Then whether you know this maximum or minima, so you double differentiate that thing and you know whether it's maxima or minima. Suppose first you want to check maxima minima, okay? So to find condition, okay, for maxima, that maxima or what? Minima, what you do? Differentiate that given quantity and equate to what? 0. You do like this one, you will get the condition, okay, that at this condition that value will be either maximum or minimum, but we don't know at this step whether that value is maximum or minimum. It could be anything, but we will get condition. To find condition for the maximum minimum, what you do? Differentiate that given thing, equate to what? 0. Okay, then you want to know whether this given that value is what? Maximum or minimum. So for minima, if you talk, what do we need? For minima, okay, what you will see? First thing that dv by dt is already 0, right? Then you double differentiate this, okay, that thing means d2y by dt square, that value should become what? Positive or more than what? 0. For minima, if you double differentiate and answer is coming positive, right, more than 0, then that value will be what? Minima under that condition. Or for maxima, say for maxima, okay, dy by dt we will equate 0, that should be 0. Then when you double differentiate d2y by dt square, that value should be what? Negative value. Then if double differentiation becomes what? Negative, then that value will be what? Minimum. Okay. Yes. Okay. So this already I have done in what? Your work energy chapter, potential energy topic. Please go and see there. Remember that formula, that force is simply equal to what? Minus du by dx, right? So they gives what? Potential energy equation to you. That's the energy varies according to this equation. Calculate the minima condition, calculate the maxima condition, or calculate energy also. So differentiate and equate to what? 0. That we get what? condition, then whether there is maximum minimum, you double differentiate this thing, then you see whether answer is coming positive or answer is coming what, negative. So you know it's maxima or minima. So this already we have used this rules in our that chapter. It will come again in few chapters. Okay. Yes. Okay. This is maxima minima. If you need an example here, let's discuss example. Suppose I write equation, find minimum value of y, okay, and y is given by some formula. Let's say I write some value 5x cube minus 3x plus 2. Some formula is given like this. Okay, we have to find what's the minimum value of v. So let's calculate condition. First, you differentiate this dy by d with respect to doing what? Okay, I wrote here. Let's write time, some time. Okay, yes, dt. So this become what? 15t square minus this become 3 is equal to what? 0. Correct. So you say that 15t square. So t square simply becomes what? 5, or t becomes what? Root of 5. Correct. Okay, let me make, okay, doesn't matter. Now you, okay, this is the time. Under this time, that value will be what? Minimum. Y value will be minimum, first thing. Then we want to check whether it's really minimum or maximum. Okay. So what do you do? Double differentiate this thing. You say d2y by dt square. What are you getting? You are getting like 15 means 30t. Okay. And this is coming what? 0, right? Minus 0. So it's coming what? 30t only, right? And this answer is coming what? Positive answer, right? Positive answer more than 0 means this value is called what? Minimum. Right. So at this condition, that value will be what? Minimum. Otherwise this time. So this time now you can put in this equation and find the minimum value of what? Y. That's all. So this already we have done in what? Our work energy power chapter. Please see that potential energy topic, the relation between this force and what? Potential energy, you will see. Okay. Okay. Apart from this, we need one more thing we need, which is very important for us. Let's call your arithmetic progression and what? Geometric progressions. These will come little later, like first use it will be in what? Our gravitation chapter, then SHM chapter and waves chapter it will also come. So I am talking about what? Progression. So first I am talking arithmetic progression, right? AP simply called, right? Arithmetic progression. So when some series there is going in a proper order, like increasing order or decreasing, whether with a common difference or, right, that's called what? Arithmetic progression, right? Yes. So suppose I say like 2, 3, right, 5, 7, you say 9. This is what an example what? AP, because every time you see that this value, okay, I wrote a little wrong here. Let's say like that way. So everything this value is increased by 2, 1, 2, 3, 3 to 5. So correct. This is example of what? An AP. So here we have two things. If you remember, we have learned that one, we have to calculate sum of nth term, right? Sum of nth term of an AP. That simply becomes what? Sn becomes what? You know, n by 2, 2a plus n minus 1 into what? D. This formula, n is the term. How many terms we want to calculate? We want to calculate sum of first 10 term, first 20 term. That's one. And a is what? Always your first term. Right now, in this series, what is the first term? Like here is what? 1. And d is called what? By what amount this series increasing or decreasing? It's called common difference, right now? Common difference. Like in this case, common difference is called what? You 2. You subtract any this to this, you get 2 answer, anyone, right? Yes. So this is what gives sum of the nth term. Okay. Yes. And generally we will not use this formula much, but the other formula of this is very important. This you want to find nth term. Like this series goes on like this one, then what is the 20th term? What is the 100th term? Okay. So nth term, you want to find nth term right now. So that formula is what? You say that t nth term is given by this formula, a plus n minus 1 into d. This we will use very importantly in our waves topics, okay, where they said there is some tuning fork will be arranged in a line. They will ask you what's the frequency of that tuning fork, that tuning fork. We will use this formula actually there. Okay. Yes. In some other chapter we will also use meaning is same. A is the first term, n is the term which we are talking, we want to find, d is again common difference, right? Right. Okay. Apart from this AP, GP will come, geometric progression. What's the difference between AP and GP? In AP like goes something values added or subtracted every time, same value, okay. Like here every time 2 is getting added, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. Here what happens? Some number will be multiplied, okay. Yes. So example, I guess I suppose some number a is there initially, then you multiply by say r, then you multiply by r square, then you multiply by r cube. So this is an example of what? GP, geometric progression. Something is multiplied every time. Okay. So here also we need to know that here mainly for us they ask what? Suppose this is going till infinite. So always they ask what? Sum of infinite GP. Sum of infinite GP, geometric progression, as infinite. Okay. This question will come at least in 10 chapters. It comes in what? Our electrostatics, it comes n number of charges till infinite they are placed, we have to find electric field and what? Force and these things. Same they ask in what? Our gravitation chapter also, n infinite number of masses are arranged. Okay, we have to find the net again, field and potential and these things. Okay, so it comes in many chapter actually. Okay, so what is here? Simple formula, sum of infinite GP is what? A upon what? 1 minus r. A upon 1 minus r. A is again called your first term, right, and r is called what? Your common ratio, means the factor by which this series is what? Increasing or decreasing. Like a was there, then multiply by r, right, then r, every time we are multiplying this series by what? R. So r is that your value. Suppose I say, you write like this one, you had 1 by 2, then you say 1 by 4, then you say 1 by 8, 1 by 16. So what is common ratio here? Every time multiplying by this series by what? 1 by 2, like 1 is there, you multiply 1 by 2, you get 1 by 2, again you multiply 1 by 2, you get 1 by 4, again you multiply 1 by 2, you get what? 1 by 8. So here r will be like in this series will be 1 by 2. So you put that value here. Okay. Yes. Okay. If sum of nth term you want to calculate, we don't need that actually. They never ask like this type. Sum of first nth term as n. Okay. This is infinite. That they are asking to us. Okay, mainly. Okay. This become a upon 1 minus r power n upon 1 minus r. But they did not ask like this to us. Okay. They have asked this question many times. Okay, in different chapter. Okay. So this was maximum, minimum, and what? AP and GP. We will use of them. We will see in that chapter. I will tell you every time. Okay. Yes. So like use of this already we have learned in our what? Work, energy, power chapter. And one use it will come again. They can ask anywhere question, but popular question I am talking. Work, energy, power we have learned about this relation. Then they will ask you in what? Your this current electricity chapter. They will ask you the maximum power transfer theorem, where we will use these things when the power will be maximum in the circuit. So we will do differentiate and what? Equal to 0, then we get the conditions there. Okay. Okay. So these were the basic mathematics. Please just remember them, nothing to understand, just remember them, use I will tell you, and it is very simple for us, not complicated at all. Only the basic things will they ask you, like this is little complicated, they don't ask to us, this they ask to us, which is very simple. Okay. Right. Okay. Thank you so much for watching the video.